Alright. Y'all ready?
Dum 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 dum.
Distance 30 meters. Down the slope. So 30 meters. Distance is. Alright. So here's our free body diagram. They pretty much give it to you. You got a normal force. The box is going down. You know, of course, the opposite of normal force is going to be mg. But it's on this slope. So of course you're going to have to break it down. Of course you'll have your mg cosine of theta and then the mg sine of theta. So we'll get to that in a second. The force of friction is going to be in the opposite direction. And then I believe that's a T. What's the total amount of work done on the sled as it moves down the slope? Total mass. That constant speed. I'm not sure exactly what that T is actually, because it's not tension. It is tension. Suppose a ski patrol lowers a rescue sled and victim. It's the tension. So they're lowering this sled from this point. So there's a person on that sled. They're lowering it down. All right. So this involves a few steps. Like, yeah, we know constant speed, but like, since there's still movement and it's not, there's still, well, let's just go through it. It says total work. Well, let's see what is it asking. What is the total amount of work done? Total work, question mark. So, and then we know as it moves this distance. So, and then we know they tell us total work is the force of friction plus the force of the range. What's that R?
Where's the R?
This part right here.
Oh, okay.
That's the.
So R. What does it say for what? Force of gravity.
How much work is done by the rope? That's by the rope. So there's a rope. Plus F of G, which we know is the force of gravity. So total work, total. All right, so we gotta break down each one of these forces. So if we start with the total amount of work of friction, so I'm gonna use a different color here. So my work of friction is gonna equal the force of friction. So how do I solve for my force of friction with this work? Maybe we could look at some of our equations over here. we were looking to relate what work is.
And it's F plus FR plus mg. What for me?
Yeah, good. Yeah.
Do you want me to tell you what each of those mean? Because I don't know.
Yeah, break down force of friction. So we know force of friction is going in that direction. You know, it's at an angle, so we can't just say that it's straight, that is zero. You know, there's some type of force here. How about this equation? Work equals F times D. Work equals amount of force times the distance. So it's asking how much force.
Go hard.
So look, we can make this same relationship. FD cosine theta. But I don't know exactly what this force is. I have a distance, but I don't know exactly what this force is. So what's my force? F equals what? Right, F equals ma, which I don't know what the acceleration really is going, so
G.
and then some
Do we know what G is?
Yeah, they don't have a
so
I said, do we know what G is?
You know what G is.
Wait, how do we get that equation? Oh. Never mind, I don't get it because mass, mg equals mass and gravity times gravity.
mhm.
So it's the basis of the equation is F equals ma, but we don't have
Oh,
the
yeah.
separation, so
Okay.
yeah. we can
Okay,
grab it.
okay. Oh, okay.
So this is very similar. So we could figure out the mg with our Newton, our normal force.
So ain't gravity, acceleration, gravity. Talking about that one? 9.8 meters, okay.
So the force of friction. So for the x direction leading from my force of friction, that's the same thing as the normal force. So I could say that I have a coefficient of friction and the normal force. To understand what the friction is doing, I need to include the coefficient of friction. And then this will be the same. I need to make sure that I have that coefficient of friction in there. Force of friction is that mu times mg. What's that? Mu times n. My force of friction is the coefficient of friction. And then how much is that friction overtaking? Well, I know it's gonna be that mass times gravity. In order for me to reduce my friction, there must be some type of mass. You know, there's that mass and gravity that we're overtaking. Or you know, that's our relationship, is that the friction is gonna be including the coefficient of friction and then there's some type of mass going down the slope. So we need that mu. So and then it's mg, mg cosine theta.
Just to be sure, that do say FD cos theta.
Yeah. So and then it's the friction. Yeah, so we know it's Fp cos theta.
Which is the same as.
So force of friction is mu times the normal force. So I could put my